Hello everyone, this is Wakana from Atago. Thank you for joining today's seminar. Today we are going to introduce our new model, PAL-HIKARi for Blueberries. Can you hear me? Okay. So here, let me explain about the revolution of refractometers. So the refractometer on the left side is the very traditional analog refractometer. The measurement method will be you pick up the fruits and juice it and put the sample on the square sample stage, close the daylight plate, and then look into the eyepiece and read the scale by yourself. So it's not going to be as accurate as the digital refractometer that we are going to introduce next. The second one is the digital refractometer. The measurement method is the same until you juice the sample and place it on the sample stage, but the scale will be shown digitally, so you don't have to read the scale by yourself. It shows digitally, so it's more accurate than the analog refractometer. And now we have the non-destructive IR Brix meter that you don't have to even cut the fruits. So here explains why you choose the non-destructive Brix meter. So it touches the surface of the fruits and measure the Brix percent. So it means you don't have to cut or squeeze the fruits. It also means you don't have to wipe and wash the sample stage after you are done with measurement. You can measure each individual fruits because it doesn't cut, you don't have to cut the fruits and measure. And it's super light, so you can hold it with one hand and you can bring it everywhere to measure the Brix of the fruits. So if you have the digital or analog traditional refractometers, you have to cut the fruits and juice it. And once the fruits are cut and juiced, it's not going to be sold in the market. But with this non-destructive Brix meter, because you don't have to cut the fruits, you can inspect every individual fruits, and you can minimize the amount of fruits that be ruined. So this page explains the tips for measurement. First, you should acclimate the fruits and instrument to room temperature because temperature really affects the measurement. So it's better to measure it on early morning if you want to measure outside because it gets hotter and hotter if you measure afternoon, like after 12. So it's better to measure it in early morning. And second important thing is to clean the surface of the fruits. So if it's not wet or ruined, it's okay. And sometimes when it comes to blueberries, there are like white small powders on the surface of blueberries, but it's better to clean the powder and measure it to get the accurate result. And third, you should avoid space between fruits and silicone cushion because if there's a space between the fruits and silicone cushion, light easily comes into the stage and it affects the measurement. And the last important point is to measure few blueberries and use the average. This is only if you want the average of the cluster. When it comes to blueberries, the Brix range spread from 9 to 13%. It's very wide range, so it's pretty normal that every Brix percent differs depending on the blueberries you measure. So if you want, measure some blueberries and use the average. And one more point. So there's a huge difference in the size of the blueberries. If you use the smaller blueberries like this one, the light easily comes through the sample stage and it really affects the measurement. The recommended size of blueberries are more than 15 millimeters. And this is our new release, the PAL-HIKARi 7 for blueberry measurement. The condensing C that you can use to cover the sample comes with the instrument. You can also use the paper cup that you can buy in public. And because the Brix range differs depending on the blueberries you measure, the offset use is also recommended if you want. So now we are going to move into the demo movie. Do you have any questions so far? No. Okay. Okay, can you see the video? I will wait for a moment because there's a time difference here. I think it's okay. Okay, we start from unboxing. So we have the instrument itself. And the condensing C that will be used to cover the sample stage and sample. We have the instruction manual and the inspection certificate with each serial number on it. And the Jordan, which is a silicone cover for Hikari, comes with the instrument as well. It will protect it from damage. So you have two start buttons here and on the side. You can use whichever start button you want. And we have also the menu button. The attachment. You have to match the hole and press it to fit. So we prepared small and big blueberries here. Just for an example, if we use the small blueberry, the N error happens because the light, it detects the light. So we should use the blueberries sized more than 15 millimeter. Cover it with condensing C cup. The Brix percent is 14.2. Just check the repeatability. We have 14.2, 14.3. It's quite stable. Okay. If you want to use the side button, you can also use it. The measurement result is 14.0%. It's quite stable. So let's compare it with PAL-1, the digital refractometer that you have to cut and use it. First, we measure the blueberry with our PAL-HIKARi. It's 16.3. Let's check repeatability. It's 6.32. And now we use the sample and measure it with PAL-1. So here we use the filter to juice the blueberry. Well, actually you can measure the pulp because blueberries don't have like much juice like other fruits. But it's better to get the juice to get the accurate result. So remember the measurement result for PAL-HIKARi was 16.3 or 2. And we check if it matches with the result of PAL-1. Please make sure to cover the prism. And let's measure. You press the start button. And we got the result of 16.0. Remember the Hikari result was 16.3. And this is 16.0 is pretty stable. Okay. So the measurement accuracy for this PAL-HIKARi blueberry model is plus minus 2.0%. And for PAL-1 it's 0.2%. So even though there were 0.3% difference between the result of Hikari and PAL-1, it's within the accuracy range. Okay. Then let's move on to the Q&A session if we have some questions. I will wait because there's some time lag. We don't have questions? Okay. Then I will end it here. Thank you for joining today's seminar. If you have any questions, you can also email us to overseas@atago.net. Do you have a question? Okay.
So Glenn Hale said there was a difference in pulp temperature.
What temperature?
Pulp temperature.
Pulp temperature?
Good question. Let's check video.
Okay. The PAL-1 and PAL-HIKARI comparison part? Okay. Okay, let's check it. The temperature for PAL-HIKARI is 29.0 degrees C. Right. And we should skip the juicing part. Okay. Then measure it. It's 26.5 degrees C. Alright, so the difference is 3.5 degrees C. Okay, let me.
Sorry, what was the PAL-HIKARI?
The Hikari temperature was 29.0. And PAL-1 at 26.5. Okay, let's check the temperature accuracy range for PAL-HIKARI and PAL-1. PAL-HIKAri. Okay, the temperature accuracy for PAL-HIKAri is plus minus 1 degree C.
Also,
And
so both of them have plus or minus 1C, so this much of a difference shouldn't be that big.
yeah, true.
Because we don't know what the real temperature is between.
Okay, so we have a temperature accuracy of plus minus 1 degree C for both PAL-HIKAri and PAL-1. So it's within the accuracy range.
So it shouldn't affect too much.
Yeah, it shouldn't affect too much to the measurement result.
Within the ATC range.
Because within the ATC range. Is it good? Any other questions? I changed it now. Sorry, you couldn't see my face. Okay, no questions. Then now I finished the presentation here. Thank you so much for joining today's seminar. And if you have any additional questions, you can email to us at overseas@atago.net. And I'll say goodbye and see you next time.